This is a data passage again. You're just quickly examining the information. What do you quickly notice? Like, where's Waldo? You see there's oceans, there's boats, there's beaches, and it looks warm. And you quickly get to the questions. It's going to tell you where to look in the question. Reminder, our DRC approach. So for data you don't read, it might be easier to remember. Just don't read. You're going to quickly skim the charts and graphs and then go to the questions. So passage 4 might look a little bit like a research passage, experiment 1, experiment 2. And if you treat it like that and read it a little more carefully, it's not a problem, but you can get through it quickly either way. This is a short one. The 2 experiments, students pull 3 blocks in a straight line across a flat horizontal surface. And the first one looks like they're looking at pulling force and block mass. And the second one, they're looking at speed and time. And then you move on to the questions. If a block was pulled towards the east, the frictional force exerted on the block by the surface was directed towards which directions? This is science knowledge. You have to understand your cardinal directions, north, south, east, west, and know that friction works against an object. So the opposite of east is west. Based on figure 2, so we're using figure 2, what is the order of the 3 blocks from the block that require the shortest time to reach the 15 millimeters per second or meters per second, doesn't matter what it is, m per second, to the block that required the longest time? So go to 15, draw your line straight across, and which one got to that line first, second, and third? 2, 2.5, and then 3, so F. Based on figure 2, so we're using figure 2 again, what's the approximate value of acceleration of the 3 kilogram blocks? We're using the 3 kilogram block. We have to know acceleration equals speed divided by time. So it's a little bit of knowledge included in this one. So speed divided by time. So I'm going to use 15 and 3. You could use 10 and 2 or 5 and 1. I don't know why I chose 15 and 3, but I did. 15 divided by 3 is 5. So your answer is B. Based on figure 1, the results of experiment 1. So now we're in figure 1. We've been in figure 2, so make sure you're looking at the correct place. So put your finger on it. The results of experiment 1 are best modeled by which the following equations. So if you're looking in the right place, speed is not a part of figure 1. It's pulling force and block mass. So we can get rid of F and G. But pulling force is. So if we look at these data points, if we choose choice H, 0.2 times 1 would be 0.2. But 5 times 1 would be 5. And 5 times 2 would be, 2 times 5 would be 10. So J has to be your correct answer, just following the equation that is presented to you. At each of the times plotted in figure 2, so we're using figure 2 again, except 0 seconds, as block mass increased, so what happens to block speed? So the block mass, is what we're looking at, goes from 2, 2.5 to 3, and as we do that, the speed gets slower, right? So it's decreased only. The speed gets slower as the blocks get heavier. Based on figure 1, so we're using figure 1 again, and we're looking for an applied force of 30 newtons. But 30 is not there. It only goes up to 25, right? It stops at 25. So you got to figure out, well, what do I do? What would be the most likely have been required to maintain the constant speed block having a mass of? Okay, so there's 2 ways you can do this. You can calculate it or you can draw it. If you calculate it, you can set up a proportion using a known data point. So force over mass. So force is 5 and mass is 1. Force is 5, mass is 1. We want to know what 30 would be, so it equals 30 over x, cross multiply, solve for x, you get x equals 6. The other method would be to draw it. If you draw it, 30 is going to be up here. It's a direct variation. It continues up. You can draw the line over until you get to the line hits. You can use your answer sheet as a straight edge, and you're going to still get 5, 5.5, and a little more if you draw it pretty good. And that's going to be 6 as well. So your answer has to be H.